But you know, now we can get the lab on a chip, so we're essentially miniaturizing this big instrument. We're putting an instrument that's really, you know, that has more, it could be more complex than these instruments alone, if we can do the miniaturization right, and we can put it on a chip, so you have this lab on a chip application. I already mentioned the personal monitors, right? So people can now non-obtrusively wear them. You can imagine necklaces or badges, right? That very simply just put on, and they track your exposure to particulate matter. And then if you have that information, you can really get a whole new dimension of data that's linked into epidemiology, right? So if you can now track, you know, the health effects of these people, right? Because that data set, continuous tracking. So there are some very interesting applications there, I think, and ample possibility for collaboration. And then, of course, now these sensors could be really inexpensive, widely deployable, right? So you could imagine actually combining the data, conglomerating the data. If there are many users with these sensors on them, you can have something like, you know, a Google Map application that tracks pollution as opposed to traffic, for example, right? So you can imagine navigating the city not based on the traffic, but based on trying to minimize your exposure. And these are just some of the possibilities. So, you know, we're very excited about it. I'm just trying to bring some applications why we think is exciting, and I am sure you agree that this technology potentially has some very, very exciting applications for us. Okay, so I already mentioned our air microfluidics group. So this is basically a research consortium between Lawrence Berkeley National Lab, UIC, UC Berkeley, and the EPA.